Hello and welcome. This is our Unit 5 graphing. We've already introduced this unit briefly when we gave the information sheet with the vocabulary, so we're going to briefly go over that. This video is about connections between graphs and tables along with their equations. So when we take a look at this, I want you to make sure you put your name and date on this. And this is our first piece of the connections. So when we work through this, we're going to be looking at the variables and patterns packets that we've been using for investigation numbers 1, 2, and 3. And the vocabulary sheet that we've already kind of organized, the coordinate graph, so a visual way to display two variables. This is very much the visual pattern. The next vocabulary word is variable, so this is the quantity that changes or varies. We've talked about ordered pairs, so this is the data point that shows the location on a graph. So that location is the key piece. Think of this like you need to walk into a building in order to take the elevator up or down. So we first go with our x-axis and then the location on the y. That's going to give us that particular location of the ordered pair. We have the variable independent and dependent items. So the independent variable is the input data, and it goes on the x-axis. The dependent variable is the output data, and this depends on the input. It goes on the y-axis. So we're going to take a look at some key concepts, finding connections between these graphs, tables, and equations in this chart below. So when we take a look at a graph, we're going to look at and we're going to go across this. So we're going to start with independent variable and where that might be located and what that looks like. So for a graph, the independent variable is data information that we are going to graph on the x-axis. So the scale on the x-axis, the title of the x-axis, all of those items give us information about this independent variable. In a table, we're going to look at the data information that's in the first column, or if it's a row, we're going to look at the information in the top row, because tables can be both vertical as well as horizontal. So if it's vertical, we're using the column. If it's horizontal, we're using the row. Next, we're going to take a look at the equation. So the independent variable is the input variable in an equation. Often when we think of this as x, it could be another item if we're doing a relationship between time and distance. Time would be that independent variable, and perhaps we would use t instead of x. So we can change the letter, but just recognizing that whatever you're using as your input variable. Now we're going to take a look at the information with the dependent variable. So as I look for dependent variable between the graph, table, and equation, I'm going to say for the graph, the dependent variable is the data information on the y-axis. So the scale on the y-axis, the label on the y-axis, those are giving me information about that dependent variable. In the table, this is going to be the data information we place in the second column or the bottom row. So again, we could have this as a vertical table or a horizontal table. We're looking either at that second column or the bottom row. And that gives us information on our dependent variable. Now in the equation, I'm going to take a look at the output variable. We usually think of this as the y. So that indicates in a table, graph, and equation what that dependent variable is going to look like. If I shift now to look at the relationship or the pattern between the graph, table, and equation, how this looks, in a graph, the pattern is very visual. It's a visual trend. It could be linear, so that would be graphed as a line. It could be quadratic. It could be exponential. And we'll get a look at what those graphs will look like on the back side of this sheet. Also, you could have a trend that might not be exactly one of these three. It could be unique, or it could perhaps fit its own model and be close to this data, but not exactly the same. So it gives us a visual cue to say, does this fit a pattern? Maybe perhaps it doesn't. And that's what this graph really shows visually. What type of a trend is there, if there is one? The table is a numerical trend. And when we take a look, we're really looking at the rate of change. How does this look from one data point to another? And then in the equation for the relationship, really this is going to be a numerical operation. Is there addition, subtraction, multiplication, division, squaring, square rooting? Are there raising to the power? Perhaps it's not just square, but to the power of 3, 4, 5, 6, all those different types of powers. What if we have a negative exponent? So numerical operations are going to indicate that pattern. So again, these are operations that impact the outcome. So if what are we doing to the input variable? What's happening to the x? Now, the last section we're looking at is the starting point or the initial value. So when I look at the starting point or the initial value of a graph, I'm going to look at the data points when x is equal to 0. Now, this could have one data point, it could have more than one data point, so perhaps it might be best to put in parentheses data points, because it might only be one. So let's do that. Okay, so really we're taking a look at the y-intercept. So when x is 0, this is really the y-intercept on the graph. So I might also add this in, the y-intercept. Okay, now let's take a look at what it might look like for the starting point for the table. This is going to be the data value when also x is equal to 0. If it's not particularly the data point on the graph, or rather on the table, then we really perhaps might need to work backwards to see what it might be when it is 0. So we can create this if we can find a pattern in that relationship that we've talked about just above. If we can find that rate of change, we might be able to find when x is 0 if it's not a particular data point. And last but not least, in the equation, the starting point or the initial value is the term that is being added or subtracted to the independent variable. This is the constant. So it has the x to the power of 0. It's the number that isn't being multiplied by the independent variable or divided, only being added or subtracted. So those are some really key points to look through, and we can come back to these as we go through and take a look at what this might look like with more information as we go along. So we have some examples. Please flip this over to take a look at the back side. So this is still working with the connections between graphs, tables, and equations. And we're going to take a look at 3 different types of models. So the linear model, which would give us a straight line and a constant rate of change. The quadratic model, which is a U shape that would be either shaped up or down. We also call this type of a graph a parabola. Or the third model, which would be an exponential, which has either it grows quickly or it shrinks quickly. So it has a unique pattern to it as well. So we're going to look at 3 different types of models and look at how in these types of models the graph, table, and equation relate to each other. Okay, so let's start with the linear, which is a straight line, and it has a constant rate of change. Now what we know from graphing so far is that a constant rate of change is going to have a straight line. There's going to be no curves. So it could be a positive straight line, a negative straight line, a flat line, a vertical line, a horizontal line. In this first graph, we're going to make it have a positive slope. And in the second graph, we're going to have it be a negative slope. This can be in any direction. I could graph a line, and I'll put it in red just to show. I could graph a line that's horizontal or that's vertical. And those all have different types of slope. It could even have a slope that's just slightly negative. So there's all these different types of possibilities. Usually, either way, we have a positive slope and a negative slope. And again, the line can be in any direction. So that's what a graph of a linear function would look like. Now, a quadratic function, we talk about it being a U-shape, either up or down. So this tells me that I have a positive x term, and then I would have a U-shape up. If I have a negative x term, I'm going to have a U-shape down. And again, this is the x squared term that is telling me if I'm going to have a positive opening up or the parabola opens down. So again, parabola is matching with the shape of this function. When we take a look at an exponential graph that grows quickly, it's going to look up. And it starts out pretty flat, and as we move forward, it increases in growth substantially. Now, exponential decay would shrink very quickly, and we would actually start our shrinking pattern, and then it would start to level off. So you can take a look at that, and that's what we would call exponential decay. So we have this as growth and decay models. Next, let's take a look at the difference in linear, quadratic, and exponential based on some of the tables. So we're going to talk about data in which we're already given the information. So we're going to have a table that's a 2-column table, and it's given to us. We're not actually trying to derive this information from the data. So I'm just going to jump ahead, and here is a table. Please copy down the values for the x and the y. The ordered pair we start with is -2, -1, -1, 1, 0, 3, 1, 5, and 2, 7. So I've got this table. I just want you to add in the values. Once we add in these values, we're going to start to take a look at what the difference is in the y values. Because in a linear equation, we're told that the first difference in the y values is constant. So I'm going to take a look at that, and the difference between each of these, in fact, is 2. And that means that it doesn't vary or change, so that would be the definition of constant. It stays the same. And again, the difference is how do I get from one y value to the next y value. When I take a look at this, to get from -1 to 1, I add 2. To get from 1 to 3, I also add 2. To get from 3 to 5, I add 2. And from 5 to 7, I add 2. So that's the difference in how I find them. How do I get from one y value to the next y value? Let's take a look at another table. This time it's going to be quadratic. And we're going to fill in the values for x and y, starting with -2 and 4, -1 and 1, 0 and 0, 1 and 1, 2 and 4. Now take a moment to fill these in, and then we're going to find the difference again. Alright, so the difference in the y values in this, we start out and take a look from 4 to 1, I actually subtract 3. From 1 to 0, I subtract 1. And from 0 to 1, I add 1. And to get from 1 to 4, I add 3. Now, the pattern in the table for a quadratic is that the first difference in the y values is not constant. That's shown here. These values are not the same. So that's good news for us. That matches. But the second difference is the piece that they're asking us to look for, and they want us to see that the second difference in fact is constant. So if I go from -3 from -3 to -1, I'm adding 2. From -1 to +1, I'm also adding 2. And from +1 to +3, I add 2. So here, that's the second difference. And it just so happens that it's +2. It doesn't have to be 2. These constants don't have to be 2. It just needs to be the same number when I'm taking a look. Alright, let's take a look at what it would look like for an exponential function. So for an exponential function, the difference in the y values follows the pattern similar to the actual y values. So let's take a look at a new table. So if we have x and y values, and here we have some fractions, and that's okay, we can work with them. We're going to start with -2 and 1/4, -1 and 1/2, 0 and 1, 1 and 2, 2 and 4. Now I'm going to take the difference of how I get from 1/4 to 1/2, and I can add a half, and that'll get me there. Or rather, pardon, if I go from 1/4 to 1/2, I can add a fourth, and it'll grab me there. If I go from 1/2 to 1, that's where I get my 1/2. 1 to 2, I get 1. And 2 to 4, I'm going to add 2. So this pattern here, when I take a look at this, that follows the pattern just before it. So if I was taking a look, and let me circle some of this, maybe I can pick a color that's not already used. Why don't we use bright blue? If I take a look at this pattern, I see there's 1/4 and 1/4, 1/2 and 1/2, 1 and 1, 2 and 2. So that's what we talk about when it talks and says the difference in y values follows the pattern, similar to the y values themselves. Now, notice they use the word similar because it doesn't have to be the same. So similar is probably the key word in here. Okay, now let's take a look at these general equations. So for a linear equation, we use the form y equals mx plus b most frequently. For a quadratic equation, we use y is equal to ax squared plus bx plus c. And for the exponential, we use the form of y is equal to ab raised to the power of x. So we have some key information pieces here. If I'm talking about linear, so if I'm here, the m is my slope, which we talk about in a graph as rise of a run. We can also talk about it as the change in y over the change in x. So I'm going to just remind ourselves of that. We can think of slope also as the change in the y over the change in the x. And when I do that, in this table above us, I can look and see that I have 2 for my change in my y. Let's do that here. And when I take a look at my x's, the change is 1. I'm adding 1 each time. So this is a slope of 2. And my y-intercept, when I take a look here, my y-intercept is when x is equal to 0. And I'm hungry, so my stomach is growling, if you can hear it. And when x is 0, y is 3. So when I write this equation, I'm going to write y is equal to 2x plus 3. And we'll talk a little more about that later. But we can really identify that from the table really quickly. Now let's take a look at the quadratic. And in this case, we have the form, and I'm just going to tell you what it is, and we can talk about how to get there a little bit later. But this is in the form of y is equal to x squared. And you can think of this as x squared plus 0, because also when I take a look here, when x is 0, y is also 0. So that is indicating, again, where my starting initial value is. And then with that being completed, let's then take a look at the exponential function. And that exponential function says y is equal to ab to the x. And in this case, this is a nice opportunity for us to take a look. And we have the equation y is equal to 2 raised to the power of x. Make sure that x is in the exponent. It's a huge piece to not get these guys mixed up. This is not the same as this concept. It's not the same as y is equal to 2x. They are completely different. One is linear, one is exponential. So we need to be really careful that we are, in fact, raising this to the power of x. Okay, I'm going to actually erase this because we don't want that on that page. So with that, this concludes our video of basic concepts between graphing, tables, and equations, and taking a look at some of our kind of basic models, the linear, quadratic, and exponential functions, and what they look like and how we can organize them. Thank you for taking the notes. We'll see you in class and talk a little more about these.